This is a pre-built version of the application. So if we go ahead and run it, and this is training data that we will be using. So this is the x1 column, and this the x2 column, and this is the label. So those are the +1 data items. They are represented with this color and shape, and this is -1 data item. And after 3 rounds, we end up with this overall classifier that classifies all the data item correctly. So +1, +1, and -1, and then +1, and +1. And it is made up of the sum of the weighted weak classifiers H1, H2, and H3, weighted with alpha 1, alpha 2, and alpha 3. And we take the sign of that summation, and this is H1, and since flag or less than flag is true, data item to this side are classified as -1, and to this side as +1, and this data item was misclassified. So the threshold is 0.67, and the feature is x1. And this is the H2 weak classifier. So the feature is x2, and the threshold is 1.31, and the less than flag is false. So data items to this side are classified as +1, and to this side as -1, and this data item was misclassified. And this is H3 weak classifier. So the threshold is 3.25, and the feature is x1. And since less than flag is true, data items to this side are classified as -1, and to this side as +1, and those two data items were misclassified. And next, let's try to classify a couple of data items. So maybe one here, 2 and 2, and another one here, 4 and 1. So it is classified as -1, and this one is classified as +1. And I will be going over the formulas used here while writing and test running the application. I will start by creating a new project, and here we will be doing JavaFX. So we will need the full JDK, and this class will contain the AdaBoost logic, and the overall classifier will be made up of tree trunk classifiers, and this will be the application driver class. So we will need a main method, and this class will contain display code, and we will be using JavaFX. So we need to extend from application, and by doing that we have to implement this method, and this is training data that we will be using. So this is the x1 column, and this is the x2 column, and this is the label. And the X array will contain the features, and the Y array the labels, and we populate both of them here. And we will need to use the commons math library to do matrix operations. So we go to properties, and Java build path, and the AdaBoost constructor takes in the features and the label as matrices, and it keeps track of those. And let's define this as static and instantiated, passing in X array and Y array as matrices. Now before going any further with the code, let's do a quick introduction. So boosting combines several weighted and specialized weak classifiers into a strong one. And by specialized, we mean that each one of those weak classifiers is good at different parts of the space, and boosting does not suffer from overfitting, and it does binary classification and produces either +1 or -1. And this is the formula for the overall classifier. So H here represents a weak classifier, and alpha is the weight for that weak classifier, and we take the summation of all the weak classifier with their weights, and then we take the sign of that summation. And our objective is to find all the weak classifier and their corresponding weights. So we start with the same weight, W, for each data item, and N here is the number of data items, and at every round the sum of weights must add up to 1, and we calculate the error rate for each classifier. So epsilon here is equal to the sum of the weights of the data items that were misclassified, and then we pick the classifier with the lowest epsilon, and we calculate alpha for that classifier according to this formula, and then we recalculate the weights W according to this formula, and Z here is equal to this formula, and we terminate successfully if the overall classifier classifies all the data items correctly. And here we will have this as a static counter that starts from 1, and this is the ID of this tree trunk, and here we are keeping track of the features matrix and the label, and the constructor will initialize the features and the label matrix, and it will also initialize the ID, and we will keep track of the feature for this tree trunk classifier, and the threshold, and the less than flag. So we use ID for naming of H1, H2, and H3, and the feature will be X1 or X2 given this training data, and we have the thresholds for each classifier. So for H1 this is threshold 0.67, and for H2 this is threshold 1.31, etc. And if less than flag is true, for example for this classifier, data items to this side were classified as -1, and to this side as +1. So this data item was misclassified. And we also keep track of the error rate epsilon, so this is how we calculate epsilon. It's the sum of the weights for the data items that were misclassified, and for H1 epsilon is 0.2, and this is y hat of lowercase h of x. So only this data item was misclassified. So here we have 1, here we have -1 for y. the label. And we also keep track of alpha. So here in round 1, this is the number that we found for alpha, and we use this formula to calculate alpha. And since we only have this data item that was misclassified, if we look at xwrong, only this one has 1 in it. And W here is all 0.2, since we start with the same weight W for each data item, and we have 5 data items. And this is the summation of alpha y hat. So alpha here is this number, and y hat of h of x is all ones, so we end up with this number here. And since this is round 1, the initial summation is 0, so we get this matrix. And for the y hat of the overall classifier, we end up with ones everywhere. So only this one was misclassified, since it is -1 in the label y. And we keep track of W previous and Y hat previous of the overall classifier. And for Z, this was how we calculate, so we have Z is 0.8, and this was how we calculate it. And we will have get methods for those instance variables, and this is for this Boolean instance variable, and some set methods, and we have this one, the get name. It uses the ID and adds each appends to it before it. And the toString method prints out this for each round. And let's go ahead and add this static method that displays misclassified data items. And I want to generate hash code and equal method for this class. So what will define a classifier is the feature, the less than flag, and the threshold. and let me move those, put them down here. And this method does update to those instance variables. Now the AdaBoost class will have this train method that executes this logic at every round. And this will keep track of all the weak classifiers, and this is a consolidated version of this. And the train method is invoked whenever we instantiate a new instance of this class. And we will first calculate W. So we start with the same weight for each data item. So W is equal 1 over the number of data items. And we will have those two matrices, the sum of alpha y hat and y hat previous of the overall classifier. And while true, we will implement this logic. So we need a method that picks the best weak classifier, and this would be the one with the lowest epsilon. So this method will do that, and let's return null for now, and we will call it from here. And we need a method that calculates alpha for the classifier that we picked here, and we calculate alpha using this formula. So this should do that. And we need a method that recalculates the weights W according to this formula. So this should do that. And let me define here those three helper methods for matrix operations. So we calculate and set alpha here, and then we add this classifier to the array list of tree trunk classifiers. And we recalculate W. and this calculates the sum of alpha y hat, so alpha and y hat, and we take the sign of that summation. So here y hat of the overall classifier is equal to the sign of the sum of alpha y hat. And this method finds the misclassified percentage of data items and returns that percentage. So we call it from here, and when all the data items are classified correctly, we break out of this loop. And what remains here is those two set methods and the y hat previous of the overall classifier. And this method will calculate and return y hat and we need two get methods for those two array lists of tree trunk classifiers. And this method makes use of this update method, and we call it from here. And let's define the number of steps to be 10. And finally, this method will classify a data item that is supplied by the user. And this will be the display code. And this code here handles command line entry. So we are prompting the user to enter values for features 1 and 2 in order to classify a new data item. And when we call launch here, we end up triggering a call to this start method, which have JavaFX code. And when we close the window, the handle command line entry method will be called. And this code will display the different rounds. So in this case, round 1, 2, and 3. And this code will display the training data. So this training data and the weak classifiers and the overall classifier. And finally, let's go ahead and test run the application. So we ended up with this overall classifier that classifies all data items correctly, and we went for 3 rounds. And ended up with this overall classifier that classifies all those data items correctly. And H1 misclassifies this point. So this is H1, and H2 misclassifies this point. And H3, so this one, misclassifies those 2 points. And let's try to classify a couple of data points, so maybe 3 and 3 and 4 and 4. So this one was classified as -1, and this one as +1.